to the session. Greeting of the day. In the previous classes, we have talked about shielded metal arc welding process, its working principles, applications and advantages we have seen. And in continuous with that, we have to see about the categories of this electrode also. We are using the consumable electrode. This consumable electrodes is categorized into 3 categories that we are going to see in this class. What is the function of this consumable electrode, which is coated with the flux material? So induces easier arc starting because we are adding the iron particles here. And then the arc stability constantly, it should not cut off in between the welding process. Improve the weld bead appearance and penetrations. For such cases, we have smooth running of welding to be there, and reduces the spatter. Very importantly, high current causes the spattering operations. But all things to reduce. So the coating on the core wire is made up of how we are making, therefore, to make this conductivity, arc stabilities, to avoid spatters, we are using hydrocarbons, low ionization potential elements, binders, and sodium silicate and potassium silicates are used in all kind of electrodes. We have 3 kind of electrodes are there: basic, rutile, cellulose. In this, all these 3 we are adding this sodium silicate and potassium silicate to act as to create the ionization process in such a way the current polarity will flow through without any obstacles. Therefore, we are adding this 2 silicates, sodium silicate and potassium silicates. So I am dividing these 3 in these categories. There are 3 distinct type of electrodes are available used in the SMAW process. We are talking about the consumable SMAW welding electrodes. Cellulose electrode, which is used for mainly, as a key point I am telling, cellulose electrode used for deep penetration. Rutile electrodes, general purposely we can use maybe for vertical portion, high portion, all portions, something is a general purpose electrodes. And basic electrodes, which contains, here in this 2, the hydrogen absorptions are there. Due to that, the defect called hydrogen embrittlement will come in this 2. To avoid those things, we are using low hydrogen electrodes, which gives the basic electrode as an advantage. We will see one by one. So the flux coating contains in the cellulose electrode, I have taken as number 1 as cellulose electrodes. What it contains? It contains the cellulose material, which is a natural compound, mainly used for creating the shielding gas releaser. We know we are not additionally supplying like a gas welding process, such cylinders are not there. The electrode which is touched in immediate, this consumable electrode creates the shielding gas and protects the environment. I told you. This causes movement of this electrode also creates the improper shielding that we have seen at the previous points. Therefore, from where this shielding gas comes? The shielding gas comes from the cellulose. It is a shielding gas releaser. So number 1 we are adding. Then we are adding titanium dioxide, a slag former to keep a slow cooling process, a warmer process, therefore to avoid this immediate rapid cooling strategies and to avoid the crack propagations. So we are adding the titanium dioxide also on the cellulose electrode in the flux. Sodium silicate are added and potassium silicates are added for the purpose of main ionizers. So what happens when this adding? It acts as ionizing components. Therefore, the fluctuations of current or fluctuations of arc initiation will not happen. If the arc is too much long, the circuitry will be disconnected and therefore welding will be stopped. The ionization to be there, plasma to be created, heat to be generated, then only the melting occurs. So this will help for more ionization methods in between the electrode and the workpieces. So cellulose burns, the same point I am telling, this point. Cellulose burns to produce hydrogen and carbon monoxide, provides the shielding to the arc. So see, the shielding is provided here by the cellulose, shielding gas releaser. Presence of these gases due to this hydrogen and carbon monoxide, presence of this is in the arc welding, high ionization potentials are generated, results in high arc energy. See, Arc energy is created now. Continuous welding can be done. No arc stabilization is there. No arc disturbance are not there. And all portion welding can be done. And therefore, all portion, what is this all portion? 1G, 2G, 3G, 4G, 6G, all portions can be done by this cellulose electrodes also. We keep the electrode and we keep the metal. This is to be melted and deposited. This is to be melted and deposited here. So what I have to do? Here the electron should flow in this direction. The impinging action to be made towards the positive. Positive should receive more heat and it melted and it deposited. So I am connecting DC electrode as positive. So what happens? Likewise I have to connect in such a way this positive will be there, negative will be here, and here the plasma will be generated. Due to these plasma actions, here in this zone the plasma will be generated. These electrons will release from the negative side and ions will release from the electrode side. Both will impinge and creates the plasma. But the flow, electrons are lesser in weight and it can able to move faster than that of the ions and impinge over the heat generated over other end of the negative. Other end of the negative is positive. The heat generated at the positive. Therefore, positive receives the heat and it melts the electrode. That is what we need. Electrode melting we need, and electrode after melting deposited over the automatic deposit over the workpieces. This V groove, V gap can be welded. V gap can be welding can be made. In specific, suitable for direct current, electrode positive. That now only we have talked. SMAW process utilizes DC electrode positive where the heat receives, the positive receives heat and melted and deposited. So the cellulose electrode will be helpful for direct current electrode positive. Results in the deep penetration. If it is high heat and high melting occurs, good fluidity we will get, and therefore we can go to the up to the 0th MO and can be welded. So deeper penetration, deeper fusion, or up to the root gap. The root gap we have to be filled. That will be helpful by the deeper penetration arc and rapid burn off rate, calling high welding speeds. What it is, we are told arc stability is there due to this good formation of shielding gas. More heat is generated and more melting is generated in immediate. Then what we can do? Even if it is heated and melted, why you want to keep slowly? We should move. We can move faster. The welding can be done faster. Our purpose of slow heating, our purpose of slow welding process is to make heating at a specific location. If it is heated, if it is melted, if it is deposited, why we want to keep our hands there itself? We can move fast to the next locations. So the burn off rate is high and therefore welding speed also high. The simple cellulose shielding gas provided improves the arc stability, improves the good shielding, improves the welding speed, improves the deeper penetrations. So such advantages are there in this cellulose electrode. But one problem is there. It produces hydrogen. Hydrogen embrittlement will come. That we have to see in the next slide. So this deeper penetration, and due to this slow freezing, it is heated but it is slowly freezing. But due to this slag former, you have seen the slag former I have written here. Due to the slag former, the heat cannot be extruded outside. Therefore, it will be slowly cooled in such a way crack propagation can be avoided. So all portion welding, especially in the vertical downward, it having good fluidity. Therefore, it goes deeper penetration. It moves immediately to the downward, and slag is found upward. So slow cooling, but it is useful only for vertical downward, not in the vertical upward. What happens due to this fluidity? If it is doing a vertical upward, the molten metal, it contains more fluid. It is not fixing there. It is and also slow freezing. Slowly it will freeze. Therefore, the molten metal will fall down. Therefore, it is not applicable for overhead portions. So that is somehow the disadvantage are there, but we can use for vertical downward. Vertical downward we can do like this. Like this we should vertical downward. Vertical upward or overhead portion, somehow it is difficult. Reasonably good mechanical properties. Mechanical properties also we are getting tensile strength, impact are reasonably good. Here the problem occurs. High level of hydrogen generated. So we are avoiding slow freezing and we are avoiding the crack propagations by the distortions, but here the hydrogen is generated. What happens? This hydrogen generated makes the risk of cracking. So how it is generated, you see, when the hydrogen is released at a higher temperature, it becomes atom, individual atom, and its volume reduces. You see, the volume of the atom reduces when it is at the higher temperature. Therefore, let us consider 4 atoms. Here, there are one more atoms are there at the center. A hydrogen atoms is there at higher temperature. Here the metal is there. Now, it is getting solidified. When it is hydrogen is solidified, its volume increases. Its volume increases. What happens? You see, this volume keep increasing. What happens? It is disturbing the nearby atoms. It is pushing, the pressure is created, the stress is created between the nearby atoms. It means the nearby metals, the molten metals. Hydrogen in between this molten material at the liquid state, at high temperature. But the same, when it is coming downward to the room temperature or otherwise, so in the state of solidification state, instead of solidification, the volume increasing, but there is no space to make the higher volume atom. Therefore, what happens? It creates the risk of cracking. It gives the pressure over all the nearby atoms. Therefore, the stress created and crack propagations are possible. It is named as hydrogen embrittlement. So to avoid this, what we should do? We should reduce the hydrogen level in the electrode. The cellulose releases the shielding gas. There we have hydrogen. Those things to be reduced, and the interaction with the environment also to be reduced. Interaction of environment contains hydrogen. That is to be reduced. Those things should be taken care. So the atom, hydrogen having volume, less volume in that of high temperature, it fixed there, it fitted there. This shielding gas absorbed from the environmental impurities and it is fixed there. But the temperature when it comes down, its volume increases and it disturbs the nearby atom. Therefore, it pushes and stress created initiates the crack propagations, which is named as hydrogen embrittlement. So where it is applicable now? It is applicable in pipelines, tanks, pressure vessels, structural parts. So we are using the high pressure vessels, tanks, pressure vessels, structurals, and the field works. In the field works, so some of the applications we can able to use there. So now the advantages and disadvantages. The deeper penetration. This is the reason we are using slow cooling, slow freezing. It goes fluidity. It reaches at last 0th point. Deeper penetration, slow freezing. Yes, the second point I have given. Suitable for welding in the all positions. What is this all positions we have named? Especially in the vertical downward, not in the overhead. Please, you should remember. Fast travel speed. Yes, fast travel speed. Good due to good arc stability. Arc stability. Due to its arc stability, we can go for speed. High heat is generated here. Large volume of shielding gas. Shielding gas is generated. What is the disadvantages here? High in hydrogen. Very important. So what happens? Obviously, the crack is created. Hydrogen embrittlement. Rough capping appearance. High spatters also generated due to this arc stability. High current is passing there. High melting. Fast process. Some molten material are spattered outside. So high spatters are possible. This is also very importantly to be avoided. low deposition rates may appear. Now we came to the second one of rutile electrodes. What is this flux containing? It contains a rutile material of titanium dioxide, which is stated as arc ignition, which takes care of arc ignition, smooth arc operations and low spatters. We avoided the spatter here. You see, the spatters are higher. This is avoided in the rutile electrodes. And we are using some clay for the binders. Many chemicals we are adding inside the flux overcovers. So some binders we are adding. And sodium silicate. Sodium silicate is following for all the three. For the basic, rutile and cellulose. So main ionizer. It means arc stabilizer. So this is classified as a general purpose electrode. Because of the rutile, because of this titanium dioxide rutile and ionizers, because of the sodium silicate and titanium dioxide, in the coating used in either polarities. What is this either polarity? It can be used in direct DCEP, electropositive, or otherwise direct current, electronegative. Positive receives heat. All positions. Good. It's vertical upward or overhead, whatever it is. So somehow this, it means fast freezing is there. Fast freezing. Okay. So then it reflects here. See, fillet welding and horizontal and vertical positions. There we are talking about only vertical downward. Here we are talking about all verticals. So it have containing the property of a fast freezing. There it is slow freezing. Deeper penetration we went. But now we want to go for the overhead positions. There what is the property we need? Fast freezing we need. We need fast freezing, overhead welding to be done specifically. Then we can use these rutile electrodes. Already it is known as a general purpose. So it contains all positions. Here also hydrogen is there. Here also hydrogen problem is there. So it gives the mechanical property of a moderate mechanical property. Good bead shape. As it is, it's fast freezing. We are getting a good bead shape over there. Positional welding can be done all positions. Easy slag removal possibles and applications where we are using these things. Low pressure pipework, supporting brackets, storage tanks, gear blanks, machineries. We can use as a general purpose welding, I told you. Steel furnitures, track bodies, foundries equipments and shaft build-up. We can able to do such applications mainly in the pressure pipeline works. Mainly in the pressure pipeline works, but it's right. The advantage and disadvantage, what happens? See, easy to use first, general purpose, easy to use, overhead also use, downward also use, vertical also use, horizontal also we can use. It is all purpose, easy to use, low cost, smooth weld profiles we are getting. Slag easily detachable somehow. Some slags, due to its warmer condition, it will be mixed over the weld pool. It cannot be removed. So that is easy here. High deposition possible with the addition of iron coders. Why is iron coders useful? Arc stability. Creates the arc stability there. Then heat is generated. Obviously, deposition will be high. Melted and deposited. If you are taking and keeping and taking and keeping, it is disconnecting. This will not melt. Then obviously deposition will not be there at the specific time. We can keep welding of the same point for entire 1 hour and deposition we can achieve. But in a specific time, how much it is deposited? Where this is possible here, high deposition rate. So disadvantages. So what happened? Hydrogen. See, the hydrogen problem is there. High volume at a lower temperature, low volume at a higher temperature. So high temperature, no problem, it is inside. But when it comes down to the solidification zone, the volume is increased and stress is created to the nearer weld metals. Obviously what happens? The crack appears. It should come out. Therefore the crack. It related to the crack. Therefore, low strength, maybe low. It means all mechanical properties, strength and toughnesses. So these are the properties of rutile. So we should come to the last one of third as basic electrodes. What it contains? So similarly, this flux contains the limestone as a gas former. Shielding gas we are forming through the limestone. Base, cellulose. Here we are using the calcium carbonate. So fluorosform of the slag former, the outer layer, the slag. And the sodium silicate, potassium silicate. See, it is following for all the three. Arc stability. Arc stability we are getting. So, and referred to as a low hydrogen electrode. Now we are coming avoiding this two disadvantages of positive here. Low hydrogen we are adding here. This generation of cellulose we are due to the shielding gas only the hydrogen and created there. You see here the risk of hydrogen and carbon monoxide are generated by this cellulose. By this cellulose. See. Now we are trying to avoid this because hydrogen embrittlement are generated. We are going to avoid this by using this calcium carbonate, and we are avoiding and we refer to the low hydrogen electrodes. So makes the slag more fluid than that of the rutile coating. We can able to make the slag more fluid. So slag is of the fast freezing type. It can quickly freeze. So what happens? Overhead is possible. Fast freezing. Suitable for vertical. So see, it is related. Overhead positions. Suitable for welding of thicker steels and steels with high carbon contents. Welding of metal, excellent mechanical property. So in the previous we have seen this excellent word we have not used. Moderate. Good mechanical properties in the cellulose and rutile. But in the basic we are giving an excellent mechanical property because hydrogen is not there, crack will not form. Obviously good bonding will be there. We will get a good mechanical properties. Right. Basic features, what are they? Welded portions and excellent mechanical property like a tensile and toughness. Low hydrogen content in the weld. Low hydrogen, relatively fluid slags. Poor bed profile as it is fast freezing. Earlier we have seen slow freezing, smoothly, the weld profile looks beautiful. But here it is a fast freezing. Melting is good, due to arc stability it is melted and it is deposited fast. In immediate it is also solidified. So what happens? The bead profile is not that much perfect as it is dropped and immediately solidified. So bead profile is not good. So slag removal also difficult, immediately freezing, so this is interrelated, these 2 points. So slag removal also becoming difficult. These electrodes are used for high quality applications because hydrogen is not there, cracks are not formed, we can use it for high quality. Some tag welding you should do, some ordinary machines whether the strength and mechanical properties are not required, only joint is required, at the time other you can use. When the property we need perfect or excellent good strength to be there, we can use this basic electrodes. So produce a weld at low hydrogen. So here also it is continuing, which produces welds of low hydrogen content. Therefore strength increases. It prevents the electrode coating from moisture absorptions. So what we have to do to avoid the moisture, we have used ovens or QS we have used. Those things we can use and baking up to the 3 centigrades are possible up to for 1 hour. 1 hour. They should be carefully stored in the and it should be dried. So these things have to be done. So basic features of basic electrodes are it is welding in the high strength, low alloy steels. Addition of baking immediately we need dryers to be used. We should heat this basic electrode. This rutile and cellulose no need of creating the ovens. But here we should do the oven and drying operations to be done. So applications welding pressure pipelines, oil storage tanks, ships, boilers. Here there are pressure created, carefully quality to be maintained there. So such examples, railway wagons we are using. What are the advantages? Advantages we are getting high toughness, low hydrogen, very important, low hydrogen and no cracks, no hydrogen, no cracks. So disadvantages, high cost, high control. If this is not there, this obviously these two are increasing. High welder skills needed and convex welds can be done. Where the fluxes are, how we are going the consumer electrode, we are using the fluxes for shielding, we know this. But what are they adding? we have seen about rutile fluxes, rutile electrode, cellulose electrode and basic electrodes. So in this various compositions they have added, such as quartz enhancement current carrying capacities and magnetite refining transformer for molten metal droplets, calcium carbonate, we have seen this in the mixture. Calcium carbonate, low arc voltage and releases the gases. This only protects for the shielding gas it gives. And fluorspar, increasing the viscosity of the molten metal for fluid flow and high deeper penetrations. Ferromagnetic metal, deoxidants, oxidation to be avoided. And then cellulose, again see the cellulose releases the shielding gases. And potassium water gases, bonding agent, rutile, titanium oxide, rutile, it's named as titanium oxide, we have seen in the table also. Increasing the slag viscosity and easy striking of the initiating of the arc and maintaining of the arc. It means a stabilizing arc occurs. So heat high generation, obviously penetration we can go ahead. High melting, high deeper penetration, high fast welding we can do. Time saving we can do there. Right. Now we come to the SMW electrode, basically composed of metal core that we know. This is the metal core and a flux cover. The metal core acts as the electrode as well as the filler rod. SMW electrode specifications by American Welding Society classification as electrode 8013B2. Likewise, they are giving classifications for the electrodes depending upon the strength factors and flux alloying systems. Alloying system going to increase the mechanical property of the metal. Therefore, we are doing this. So see, this image we have already seen. At the center of the core wire is there. Maybe the filler metal addition, flux also, we can able to do the alloying system, whatever it is. But later I am doing these cases. You see, this I am doing. So I have named E8013B2. What it is then? So this E belongs to electrode. We should identify in the market. We are going. Let us consider the supplier want this 80 KSI of tensile strength. A manufacturer want to purchase this 80 KSI electrode and weld. In case supplier wants the 70 KSI of tensile strength, they have to purchase E7013 electrode and purchase and weld. If you are welding through this electrode, what happens? This alloy system contains, the coated alloy system contains the alloying materials which gives that 80 KSI strength factors. Therefore, we should purchase this. So, by the AWS, they are defining this like this. If the E belongs to electrode, this next two letters, 80 belongs to tensile strength in measured in KSI. And this number 1 belongs to the positions. What is this positions? This electrode having the good solubility, good withstanding property. So we can able to go to the overhead, it will not melt and falls down. So here 8013 belongs to positions of all 1G positions or 2G positions, all positions, so that it determines. And then this 3 belongs to type of coating available. What coating we have given? Such coatings we are defining in this number 3 as the fourth factor. E first factor, KSI, positions, all positions, and 3 it belongs to the coating. And then the B2, it represents by the supplier manual. B2 belongs to the chemical composition of the weld metal, how much it is on the deposited zone. So this factor we have to understand and keep moving for purchasing and welding. So this we have to know about the how far this AWS classifications have defined this numerical numbers identification of the electrode. In continuous with that, few examples I want to give you in the electrodes, such that in this American Welding Society A 5.5 alloying systems, we can able to see. So this various causes are there. We have taken their naming the electrode in such format E7018MG. What are they? The supplier gives the name by with respect to standard of AWS. We have already seen this also. Such examples, this image we have seen, they have given like this. So few examples I want to give you here. At first, E represents the covered electrode E represents the covered electrode, and then the 70 represents the tensile strength value, and then the third one, the 1 represents the welding positions, maybe a 1G all positions. All positions represents the all positions, and the 8. Next one, 8 represents the flux covering, whether it's a rutile covering, basics covering, cellulose covering. With respect to that, we have to see the manual. This 8 represents which covering methods. We have to see the supplier manual with respect to standards. And then the M represents the moisture control, how much the presence of moisture can be absorbed, whether how much it's to be baked, 300 degrees centigrade, 150 degree or Q or 70 degree. That the conditions we have to refer and purchase. These all affects. See, at last one, G, alloying content. How much? For improvement of the properties, we are adding some alloys. For shielding gases, we are adding, not only we have seen the tables, how much, what alloy is added there. So such combinations we can able to see in AWS A5.5 standards. So these are the things. We have to, the flux covering is important, welding positions. If you are purchasing from the supplier the electrode for only usable for flat positions and it does not having quick freezing, we cannot able to use the overhead positions. So this represents, 1 represents here all positions. If you are purchasing other positions which are only suitable for flat welding process, it means fast freezing ability, alloying is not added proper. If you are purchasing and we are welding over the overhead portions, it causes the damages. So that we have to look over all these things, alloying systems, moisture welding, tensile strength. Finally we need, after welding, it should be withstand the strength factors. Therefore we have to look over this and we have to purchase from the supplier. Similarly, one more example I have given with respect to AWS A5.1 bar 5 example of electrode flux types. See, we have seen already this is cellulose flux, rutile flux and basic fluxes. In this, the cellulose flux, for the identification I am telling, it ends with zeros and ones. You see, E6010 and 101. And then rutile flux ends with 2, 3 and 4. You see, it's researched with the 2, 2, 3, here, I am telling here 2, 2, 3 and 4. Such that we understand by seeing the number in the industry, here one welding will runs and that side one welding will runs. With respect to that, they have using different type of electrode for the different application with respect to different alloying systems for the different components. Maybe pressure vessels, maybe boiler plants, heads. So this alloy system with respect to strength factors we are using. Therefore, this represents which one? One represents the cellulose. With respect to those applications, they are utilizing this one. Let us consider I am the welding engineer. I am going for the inspection of which electrode they are using there. In immediate I can able to see the electrode, the printing will be there and checking. So this is belongs to rutile flux. We can able to see, and we have to see the specifications whether which electrode to be used there and whether their welders are only skilled with respect to welding. They don't know how much technical. This whether they have to use 0 or whether they have to use 2 rutile or cellulose. They go, they take and then they start welding. And if it overhead is not possible, they will get the damages. They will get the accidents. So this is our welding engineer's duty to check those things whether they are using the proper electrode or not. And then see the basic flux. The idea, it ends with 5, 6, 7, 8. For example, I have given, see, E60, 60 belongs to tensile, E belongs to electrode, 1 belongs to positions, and 6 belongs to the basic fluxes, ending flux combinations. How much flux we are using? 6, 7, 8 and 8. See, for examples I have given here. And one more with respect to British standard 6039. Up to now we have seen the American standards AWS. So here the British standard 639, here also they have divided into some other categories such that see E belongs to The covered electrode, similar pattern, but some additional information they have added here. And then 51 belongs to yield strength or tensile strength. This 33, the next double factors. The 33 belongs to toughness. Next one, the B belongs to flux covering. This belongs to the basic fluxes. In the same point, in the 1, 2, 3rd, 4th category, they may have cellulose, they may have rutile. In case rutile, we have the R will be there. So, and then the next one, it belongs to weld metal recovery iron powder content. How much iron we are adding for the arc stability? Higher the ions. Likewise. And then at last, 2 represents the welding positions. 2G, likewise, we can able to understand. We have to see the manuals. What positions 2 represents. And then at the last, 0 represents the electrical characteristics, DC or electronegative, electropositive, which will be useful. Otherwise, it will be for the both polarities. AC also possible. Such cancels we can able to see from here. At last, hydrogen content. I told you during study of this rutile fluxes and cellulose fluxes, hydrogen contents are there. Hydrogen embrittlement will take place. Presence of hydrogen, the volume increases when it comes to the temperature downwards. Therefore, this hydrogen content to be less, here this H represents, here the point will be given there. This electrode, you have to see the specifications, how much hydrogens are there. Accordingly, we should purchase. Less hydrogen content is preferred. So some other examples also similarly I have given there. Covered electrode, tensile, toughness, chemical compositions, flux coverings, welding positions, hydrogen content. Some few examples with respect to British standards 499. Right. So the summary, in welding we have seen about today the types of electrodes. In these types of electrodes we have seen one as basic, cellulose and then rutile. Here no hydrogen, good properties, and here there are hydrogens are there, presence of hydrogen. Here also presence of hydrogens are there. So this is how the types of electrodes we have seen. The remaining part of the subject we will see you in the next session. Thank you.